All right, here we go again. So starting with problem 6, we're going to be solving for x. So what we're going to be doing on these problems, and the idea is we are not using our calculator, this will be on the non-calculator portion of the test, is that we aren't as comfortable with logs. So the idea is trying to figure out what x is. We want to turn these into exponents. So this is where, again, we're going to kind of start to look at, making the e. Eventually, we're not going to be making the e. The idea is, you're comfortable with that, and when we get into the inverse and solving part, you don't necessarily always have to make the e. But when you do make the e, starting with 6a, we always start with the base, x, and then as we make the e, we go to the other side of the equal sign to the third power, and then we come back to the original side of the equal sign, and we get the 27. So what to the third power gives us 27? You can use your exponent table, and you will see that that x is worth 3. So we're not just changing it, we're actually trying to figure out what x is. So b, there is an understood little 10 here. So again, if you don't know what the log of 1 is, or the log of 1 with the base of 10 is, turn it into an exponent. So 10, go to the other side of the equal sign, x, come back to the original sign. So 10 to the what gives you the first power? Well, anything to a 0 power gives you 1. Next one, again, 2 to the what power gives you 1/8. So remember, negative exponents are what's making this a fraction. So we're going x is definitely going to be a negative number. So that kind of takes care of this one part. So 2 to the what power gives you 8. That's going to be a -3. And then our final one, this is going to be the toughest one. So normally this is a problem you could just type into your calculator, as with this one. Even this one, you could type this into your calculator. But again, how do you do this without the calculator? So 25 to the what power gives you 125. So using your exponent table, first, it doesn't go up to 25, and even if it did, there is nothing that you can take 25 to a power 2 to get you 125. So we're kind of going to go back to what we did in the first part of chapter 6, and we're going to find a common base between these two, and that common base is going to be 5. So 5 squared is 25. So now it's 25 to the x power, and 125 is 25 to the third power. So now that when the bases are the same, you could ignore those bases, the exponents become the problem, and to solve for x at this point, just divide by 2 and you get 3/2. And it's probably just easier to leave this as a fraction. All right, we're going to be finding the inverse. So the first big step of inverses is if you see f of x, just change it into y. So I'm going to do that on a and c. And then the next big step is to switch x and y around. So that's what I'm going to do first on all the problems, just so you get that idea. Keep going, so you can do this too. And the last one. Now, when I write ln, I will write that there's an understood little e there. Whoops. Let's change this. That y should be an x. All right, so our job is to now get the y by itself. We got to solve for y, because that's what a function is. A function is when y equals everything else. So what I told my students is the first thing we're going to do is we're going to go to the original problem. So for instance, 7a is an exponent problem, and I'm just going to circle the base in the exponent. So when I go to 7b and it's a log problem, I'm just going to circle the log. So the log has a base of 2, but the log consists of the stuff that's behind it. So this is the log. The 3 is multiplying to the log, but that's the actual log. So when I go to c, this is an exponent problem, so I just want to circle the base in the exponent. And when I go to d, I want to circle the log. So this natural log with the base of e, all of this is part of the log. And I know that all of that is part of the log because that y plus 2 is wrapped in parentheses. If it had been written like this, which I'll erase in just a moment, whoops, then this is part of the log. That too is signifying that it's not, or I need parentheses for it to be circled. So okay, let's erase that. So now we're going to start. So my job is eventually to solve for y on a is I'll have to turn it into a log eventually. But before I can do that, it's got to be just the base and the exponent. So what I'm going to start first with is I'm going to draw a little wall, and I'm going to move the 2 to the other side. Whoops. Let's fix that. All right. So first I'm going to move the 2 to the other side. Since they're subtracting, I'm going to add. So this side just becomes x plus 2. And again, remember, this is circled. So what I'm trying to do now is solve for y. So some people might think, well, I'll just divide by 24, but the 24 is not multiplying to the y. The 24 is a base, the y is an exponent. So the only way to get to the y is to just get rid of the whole exponent problem. And the opposite of an exponent is a log. Just like the opposite of subtracting 2, we just added 2. So what I'm going to do is turn this into a log now. So here we go over here. It's going to be log. And the base of the exponent is the base of the log. And then if you're making the e, remember you go to the other side, it's going to be of x plus 2 of all of it. So to show it's of all of it, I'm going to wrap it in parentheses. Then I'm going to come back to the other side of the equal sign and I'll get the y. So it's a function when y equals everything else. So when I look at what I've just written, y is alone, it is by itself, so this is the function. And then what you can do is actually turn this y into the function notation of an inverse like that. So y or that, either way, that is the inverse function. All right, so going on to b. So again, I need to get y alone. I've circled the log. So when I look at what's not circled on this side of the wall, is I have a 3 multiplying to it. So the first thing I'm going to do is just move the 3. And since it's multiplying, what I'm going to do is divide. So I divide on the left side, and that just takes care of that 3. It's gone. And on the right side, I'm going to have x over 3. So just 1 second. All right, x over 3. So I have this on the left side, and I have x over 3 on the right side. And again, remember, we circled this. So now my job is to get y alone. So some people think, well, let's just divide by log 2 because that looks like it's multiplying to y, but it's not. Log base 2 with y, that's the whole log. So the only way to get y alone is to get rid of the log, and to undo a log, we're going to turn it into an exponent. So again, what I'm going to do is start with my base, and let's get a different color. It's going to be 2 to this power. And when I come back, that's going to equal y. And again, it's a function when y is alone. And y is alone, so you could write y, you can write it as that inverse notation of a function, but this is your answer. And I just realized on 7, I did an e. I shouldn't have done an e. I apologize. I should have done a log. Log 24 of x plus 2 equals y. So I just realized that, wasn't paying attention. Okay, moving on to c. So again, I need to get y alone, and so I circled my base and my exponent. And what's not part of that whole side is the 4. So what I'm going to do is move the 4 to the other side. Since they subtracted, I'll do the opposite. I'll do the inverse, and I'll add it. So this is what I have on the left side, and on the right side I now have x plus 4. And again, this is circled, and I want to get y alone. I'm not going to subtract 4 because 4 is in the exponent. I'm not going to divide by 6 because 6 isn't multiplying to y. 6 is the base of that whole exponent of y plus 4. So the only way to get y by itself is to get rid of the whole exponent part, and that means I'll turn it into a log. So first thing I'm going to do is write the word log. And now I'll do this correct. It's log. Remember, the base of the exponent is the base of the log. I'll go to the other side of the equal sign. All of that is going to be x plus 4. So to show all of that, I'll wrap it in parentheses. And then I'm going to come back to the left side of the equal sign, and that's going to equal y plus 4. And now it's a function when y is alone. Y is not quite alone. There is still this 4 here, so I'm going to move that to the other side by subtracting. So when I'm done, here's my answer. Here's the log. And then I'm going to subtract 4 and make it y, and you can turn y into this. What I'm not going to do is take these 4's here, subtract them, and make them 0. The 4 in parentheses is part of the log. The minus 4 is not part of the log. So this is your final answer. And moving to D. So again, my goal is to get to y. You don't subtract 2 because that's part of the log. You don't divide by natural log because the log is the natural log of e with y plus 2. So the only way to get y alone is to get rid of the whole log, and to get rid of the whole log, I'm going to turn it into an exponent. So this time, making that e isn't going to work. You're not going to have a pretty e. You're going to have something that looks a little different. So if you really want, just remember, you're going to start with the base, okay? And then you go to the other side of the equal sign, and then you go around it, so e to the x, and then you come back to the right side of the equal sign and you get the y plus 2. It's not quite an e, it's a backwards e. My class said it looks like a 9. Anyway, I'm not done yet because the function is y equals everything. The y isn't alone, so I'm going to move the 2 to the other side, and I'll do that by subtracting. So when I'm done, here's my answer as y, or this. And there's your final answer. Okay? All right, let's move on to the next part. All right, so first thing we're going to do is we're going to be solving. So again, when I talked about solving, the first thing I want to do, is it equaling a number or just what I call a constant or not? Because if it's equaling a constant, so what I mean by a constant is I just got this random number here, like -2, 200, 119, this. But on E, I got a log on one side and a log on the other side. But F, I have a constant. So just kind of these first couple problems, how I solve those, I'll be turning them into their opposite form. So if I see a log, I'll be making an exponent. And if I see an exponent, I'll be making a log. So the first thing I'm going to do on 8 is just, excuse me, what I want to do is realize that with this problem, that the log isn't negative. There's actually a 1 in front of it multiplying to the log. I'm going to make that look like a capital L. And I'm going to add the opposite on it. So the log is not negative. There's actually like a -1 multiplying. And the next thing I'm going to do, just like I did in the inverses, is I'm going to circle just the log. So this part is the log. Everything else I will have to move to the other side. And so I'm going to start. So the first thing I'm going to do is subtract 4. So on the left side, I still have this -1 with my natural log of x. I'm going to keep that circle. And on the right side, what I have is -2, take away 4, I get -6. And again, I got to get until it's still only the stuff that's circled. So I'm going to move the -1. The -1 is multiplying, so I'm going to divide it. So what I have now is the natural log, which has an understood base of e, and I have a 6. So now to solve for x, you're not going to divide by ln on both sides. This is the entire log. So the only way to solve for x is to get rid of the log, just like we did in the inverses. And the only way to get rid of a log is to turn it into an exponent, and that's what I'm going to do now. What I'm going to do is, if you want to make your e still, great. It's going to be e to the 6th power equals x. So whatever e to the 6th power is, let's see, did I write that down? I gotta get to the right page. Hold on 1 second. Yeah, it is about, the directions say to the nearest thousands, 403.429. That is x. If you want to just leave it as e to the 6th, you could also do that. I think that would be fine. All right, on B, I'm solving for x. So again, what I'm going to do is first I'm going to draw my wall. The next thing I'm going to do is circle my base and my exponent. My base is e, and my exponent is -x, or -1x. That 5 is not part of the base. There's only one base, and it's e, which is about 2.7-ish, close to 3. So my job is to start solving for x, is to get x alone. So first thing I'm going to do is add 18 to the other side. That gives me 218. Again, I'm just going to keep this base circled. So now to get my base and exponent alone, I'm going to divide by 5. So I'm just doing this on my calculator. So 218 divided by 5, I get 43.6. And now, to get to that x, I'm only left with the base and an exponent. And the only way to get to x is to get rid of the whole exponent. So I'll be turning it into a log. So I'm going to do that over here. And again, log, the base is going to be e, which will just turn into ln. So I'm going to switch that to ln now. So if you want to see that whole L thing, so log e, or ln, with this decimal, 43.6, is going to equal this -x, which is actually -1x. And so now I'm going to turn my calculator, and what you're not seeing is I've pushed the LN button and 43.6, and I get this really long decimal. So what I want to do is keep that long decimal in my calculator, but for this I'm just going to show some of the numbers that you should be seeing.